Okie dokie, I've just started the recording. So welcome to our June episode of Mums Returning to Tech. So I'm Renee, as always, and we've been missing Sarah for a while, and Sarah's replacement, Nadia, has just joined us. So hopefully we'll be able to get the videos and stuff circulated a bit more quickly because we've now got our team back together, which will be great. So maybe Nadia will visit us in a future session, I'm not sure, but she'll be helping out in the background at least. Just a reminder about code of conduct, always to be kind and aware of others and respectful, and be inquisitive, ask questions. And so we'll be recording today's session, as I said, and circulating this after the event, so you can catch up if you've missed out, if you're watching this at home. And we've got these are the same links. We hope you're going well on your pre-work if you're still going through some of that stuff. And we've got our coursework as well. And you can always get in contact with us at reactorsid@microsoft.com, and Nadia will get back to you there. We've got our LinkedIn group as well. Why is it showing my hidden slides? There we go. Today's technical session, we have Vic Perdana joining us today, filling in for George, who couldn't be here because of family emergency. So thank you, Vic, for joining us at the last minute. Vic has over 17 years of experience in cloud infrastructure, DevSecOps, and development. He is currently working with partners to help them grow with the power of elastic cloud technologies, which maybe we'll hear more about today, such as Kubernetes, app services, and CosmosDB. And he's an avid learner in anything DevOps, cloud native, and open source. Today, he's going to be taking us through teamwork and testing, how containerization and CI/CD simplified the dev cycle, and how, good code and good teams rely on testing, continuous integration and deployment tools to make testing code easier for teams and deploying code as well. So we're going to learn some best practices about testing your code and automating testing and deployment stages to help your team work faster together. So with that, I'm going to stop sharing my screen and I'm going to hand over to Vic. And you can tell us all about things. I'm very excited for this session because I do want to know more about containers myself. So
Awesome. Thank you, Renee. And that picture somewhat doesn't look like pretty old. It seems that I'm still kind of resembling that a little bit. So
I stole it from LinkedIn.
Even though it's 10 years ago, probably I took that the picture there. So thank you again. I'm just sharing my screen now. So so quick intro. My name is Vic Perdana. So I'm Cloud Solution Architect from the ISV team here in Melbourne. I'm working with a lot of ISV and SaaS companies in Australia and New Zealand. Previously worked as a customer engineer or premier field engineer in the kind of support, proactive support land. And before that, spent most of my time working in consulting. And George is actually, who's unfortunately away on compassionate leave today, he is still my colleague, and we used to work in, spend a lot of time together in consulting world and work in previous same companies as well before Microsoft. So I know him really well. So I just bear with me. I cobbled together this presentation quite last minute, so it's not fully polished. So it was obviously family emergencies and so on, and obviously George didn't get a chance to actually put together the slide deck. So just bear with me as I put together this. But if there's any questions, more than happy to answer and try to basically facilitate as much as I can. So first of all, I'd like to begin by acknowledging the traditional custodians of the land on which we meet today. I would also like to pay my respects to the ancestors and elders, past and present. I would like also to acknowledge the traditional owners of the New Zealand people. Cool. So quick agenda. Again, I put together this pretty much last night. So a bit of introduction, about myself and what I do kind of in my outside of the tech world. Because this is return to work and mum return to sort of tech. I can sort of share because I've got 2 young toddlers at the moment. I'm also going to be talking about the overview of kind of containers, a bit of introduction on containers, as well as CI/CD, and I kind of spin that kind of into a team activity. So basically, anything that we do kind of in dev and DevOps and all of the CI/CD stuff won't mean anything if you don't have teamwork. So it's all a combination of process, people, and technologies together. So that's something that is important to acknowledge, that it's just not only technology, but also people that are working in there. Just like with anything in life, really. The other thing that I'm going to be talking about with containers is that there will be, basically modification or some adjustment as we use containers in our tech stack, and on top of that as well, introduce you to the world of cloud native, which is basically there's a body that's non-profit body that sort of governs cloud native, and have done a number of certifications and so on any projects that are kind of certified, and how again Microsoft can play a role in that. And finally, no one can escape from the world of co-pilots and AI and ChatGPT. So I thought I'll put in there a quick perspective on how AI would impact developers and development in general. So I think that would be interesting sort of tidbits that I'm sure I guess everyone will be interested in. Cool. So that's a little bit about the agenda. So a little bit intro for myself. So we're a family of four. I've got two kids. Again, the picture doesn't do justice given that it's two boys. So and by the way, I generated this using AI. So you can sort of judge yourself how AI come far away and how much we can sort of rely on it at the moment. It's very early days. And I recently took parental leave. So this topic is quite close to heart. I took about 3 months parental leave, and also 4 weeks. So basically, we are able to kind of split the leave quite a bit. And we have 3 years old and 1 year old, and pretty much they're born during the COVID era, so COVID babies effectively. And it's not always as moms know, and I work basically with, I know firsthand. My wife is going to go through the process of, basically having the kids and during the COVID, and it's a lot of work. It's a lot of challenges. Obviously raising kids, and probably even if I compare it my career the past 17 years or so, I wouldn't even compare that. It's pretty different level. So yeah, really appreciate anyone who's willing to take part of this challenge and to basically get in and transition back to tech. And that's it's something that cannot be underestimated. Cool. So that's a little bit about me. And first of all, I'm going to talk about is introduction to containers and CI/CD. CI/CD is basically continuous integration and continuous deployment. So that's something that we're going to talk about today. At any stage, if there's any question, I guess this is a bit of a private session for us, given that we have only 3 of us here. But yeah, if there's any question, just feel free to just unmute, or if you want to type in the chat window as much as I can, I'll try to answer it at the end. Cool. First of all, what is a container? So we can sort of picture a container like a real container, physical container, in the supply chain world and logistical world. Anyway, it's not too different in kind of the software and IT world. So it's a method of again, trying to make that in a software term, it's a way for you to have a visualization of container that allow you to sort of package up things within the containers. So in the IT world, effectively, it allows you to run an application and its dependencies with resource isolated or processes within that. So you basically have think of it like if you watch a lot of kind of house shows where things are, people are living in containers. It's kind of similar to that. So effectively, you have a mini house within a container, which has everything that you need, which is quite self-sufficient. Another kind of aspect around container is that there's a lot of challenges before the world of container, where you deploy an application to a server or to a VM. People say it works in my environment, but it doesn't work in another environment, right? So if I deploy it to another location or another server, then it doesn't. There's some issues with it, whether that's dependencies because of libraries don't exist and various things. So all of that is something that is resolved, or what containers try to resolve. So containers enable that automation and flexibility required to operate what we call microservice. And we're going to talk about microservices as well, a little bit about kind of the architecture of that and why that is an architecture that can easily or can be suited best for containers. Cool. So why containers? Again, we sort of talked about it. Again, it's there's a certification at the end logo. It says works on my machine. It doesn't work. It doesn't mean that it worked on another machine. So that's really about consistency, about having kind of giving a high level of assurance that whatever application that you're deploying, it's part of that self-contained unit that can be ported to different location or different machines. So that's really the gist of it. The idea behind container is that. So what's the difference between containers and VMs? So we probably heard about virtual machines and servers and so on, right? So server just like pretty much our computers, as well as kind of physical machine. And within that, you could have typically you have an OS, an operating system, but then you could also have visualization layer, what we call hypervisor. And within that hypervisor, you'd be able to kind of look at the various, you basically be able to kind of separate or logically separate different workspaces, if you will, for different guest operating systems. So you can have multiple guest operating system here, and each guest operating system operates independently, which means it's fully isolated. And you can then put different frameworks, different applications, and everything else, and it can be also migrated from one physical server to another physical server. Whereas containers, it is different, as in it takes that concept of hypervisor and guest OS to kind of the next level. So rather than having multiple guest OSs, this one, right? So you have that, you have that. You basically have just one guest OS, and what you could do, you set up kind of bunch of a framework within that guest OS, which is required for your runtime of your application, and then you set up containers within them. So effectively, as you can see, the number of apps that can be kind of placed into a physical server, basically maximizing that density of number of applications that you can place into that. So it's very effectively very efficient. It is something that a lot of customers like because it maximizes their investments. Say they invested uh, X amount of dollars on certain hardware, they'll be able to put more into that because it's pretty efficient. Cool. Efficient use of hardware. So this is again we talked about that. So containers run without virtual machine. Container relies on those host kernel such as the file system, the network management, and so on. So compared to a VM, it's a lot more dense and a lot more kind of portable, right? And it actually requires less disk space, memory, and CPU because you're removing that guest OS component there, right? So you don't have that guest OS. You care about kind of ensuring that you install the libraries and then you can deploy different applications in them. Cool. Some of the, I guess, concerns about containers is that with having different OSs, you have full isolation, and this is something that containers have made a really big strides in that. And by the way, Docker is basically one of the container runtimes. So probably saw that in the image there. It's not. It is container still, but we do have different runtime, and Docker is one of the most famous Docker runtime. It's a company that provides that container runtime. So containers provide that security, and one of the major improvements around that, it has the ability to isolate different containers to another, and ability for you to be able to share data as well within containers. So that's another thing as well. If you don't actually specify any kind of volume within the containers, then you won't be able to access data. So it's all secure by default. And see here, we've got, say, hey, I have a physical host running 2 VMs, and we have 3 applications. We want to run isolated isolated application. So we can put the VM OSs here, right? Or what you can do, you can just effectively continuing this pattern, right? So you have another VM, and that is not efficient because every VM will effectively needs an OS, and it needs usually a lot of memory to run. Alrighty, so a bit of a quiz time. I know it's pretty short, but we'll just wait. I guess it's only 2 of us, or 3 of us. So what is a container? Anyone wants to take a guess quickly? Oh, Lawrence, hi, Lawrence. Thanks, Renee. VM virtual machine. So what is a container? Is it A, physical storage unit for files and data, or B, a lightweight standalone executable package, or C, a software tool to manage source code? Brilliant. Excellent. Got them right. Excellent. Thank you. Alrighty. So let's have a look at what is container in a Flash, right? So what does that contain of? Basically container contains of. It's how we typically build a container. It is basically a file or definition of your of your application, right? So it's like a definition of, or application declaration, or definition of application. So a number of libraries that you need to define, and then containers will effectively be built as part of those various kind of definitions and images that you have defined. So we have, this is an example of a Docker. Again, Docker is one of the container runtimes. And what I have here is that I've got I define a container first as a base, right? So I call that as a base. So think of it as a number of layers that you put together in order for you to create a container that you can use in your application. So this one here, I have a container that calls an image called ASP.NET Core as a base, and the work directory of that was the application going to be mounted in, as well as the exposure of number of ports, whether that's HTTP or HTTPS. So basically, I've got 2 ports that I want to expose, and then from there, it's completely separate, right? So this is something that you build as a separate image, or a separate image that you're going to use later on in your final container image. So here's with work directory of source, and then what I'm doing, I'm actually copying a number of files, a number of projects, in .NET, or in Python might be different. And in .NET, this is something that you typically sort of specify different files of the application that you can then use in order for you to run that application. So I perform these copy functions, right? So basically, I've got those things, and then what I do, I run a kind of a .NET restore. So this effectively perform any dependencies that are required to get to basically define in that file, which is that CS_proj file. And then I'll just copy the source and the work directory back to that. Copy the everything that's in the source, which is here. Basically, dot means that it's actually within the same directory, and just copy it within that directory. And then the work directory, I change that again to contours of traders API.products, and then run a .NET build. And this build effectively build the application, build the libraries, and then I output them to a directory called app build. And then I use build, as you can see here. So there's a bit of a, let me see if I can just push that in, right? So build, and then I can see build as well. So that's the same build that I'm referring to. And within here, I then specify everything that I have. So basically, it's just a copy of that image, and then I'll run a number of commands there to .NET publish, and from here, from base as final. So this one here is that I'm choosing the base again. So let me just get that one there. So right, so base, then that's base, right, and that's will be my final image. And within here, I copy from publish to from publish. From publish to app publish, and then to dot. So basically copying the file that in here within this app publish to the current directory, which is app. And then I set up the entry point, which is saying when you run this container, this is going to be the library that you need to run when you effectively run this particular container. So that's pretty much is our container, right? So this is the whole thing here in the box, yellow box here, orange box. Is basically our container that contains our application. So that's effectively how you build a container from scratch. And most of the I guess there's maybe a number of variations around this, and depending on how complex your application is, this kind of gives you an idea that effectively containers are built based on layers, right? So you've got one layer for your base, and then you build as a separate image, and then from of that build, you actually use a use copy to different name here, or kind of an alias here, publish, and then from there you use you basically copy the result of the build process to the final image, which is that in the green color there. So what you get is basically you got the ASP.NET Core as the base, which is your base image, and then you also get you don't get the SDK, right? So the SDK, you don't really need that for running the application, because that's only required for the build. And what you need is basically the runtime libraries, which is that as a result of that app publish command there. So, sorry, .NET publish command. And then you then use that as your container. There's a bit of a number of things to unpack, especially in the morning, but please let me know if there's any questions. Cool. All right. So let's move on to the next stage. So that's pretty much the basic of containers, right? So if you know about this concept, if there's any sort of takeaway, this will be something that you probably want to remember, so that it's easier for you then to when they talk about containers and Dockers and various things, it's basically layers on top of layers, and then you build on top of different images. Cool. So let's move on to team sport. So I did sort of preface a little bit before around anything to do with technology. If you don't have the right people and processes, then it won't probably won't achieve the outcome that you need or outcome that you want in any project or any I guess any aspect of our life, really. So the idea there is that there's consequences of inefficiency, right? So if you aren't able to get the right balance between those three aspects, you've got this different organization, different parts of the organizations. Like developers, you've got IT ops, you got the business, right? So they have different expectations, and they probably see the world in a different way. And there are real consequences if you don't actually get our efficiency in the right balance. One of which is 40% of implementation had to be reworked, and this is based on some research on IDC. And the average cost of 1 hour downtime of a customer-facing app is calculated to be about 100K per hour, right? And this does not take into account the damage into kind of reputation and various brand sort of damage there, right? So you've got, and it takes an average 200 minutes to diagnose and repair production issue. And only kind of 3 out of 4 teams have adopted agile methodologies, and this is something that some customers that I previously worked with, a lot of them potentially have 1 or 2 teams, or maybe 3 teams have already got sort of agile and have some DevOps practices inside them, but it doesn't, or they don't actually apply to the basically the entire organization. So there's a little bit of variation, and as a result, it impacts in efficiencies. So, there's a number of things here as well. Basically, 70% of CIOs says that, if you don't actually deploy or have efficiency or the right processes in place, it would, 70% of CIOs says it would increase risk. And they want to reduce IT costs as well. So a lot of these are pretty, pretty significant in terms of the costs of not only basically the money, but also kind of non-tangible costs as well. So with that comes this probably a few years ago now. It's already like 2014, 2013, probably around that time. The concept of DevOps became really popular. Maybe a bit before that, and a lot of people were using DevOps in different ways. And effectively, some people say, DevOps is a title, it's a job title. And it has effectively different meanings to different roles in organizations. Some also feel that it's a bit of a buzzword. Others are more informed and various things. But the idea is that DevOps is all of them, right? So what we can see here, DevOps is development and operations collaboration. DevOps is treating your infrastructure as code. DevOps for small deployments. All of that is relevant to DevOps. But at the core of that, DevOps is basically around those three components. I did sort of mention that at the beginning, is that you've got people, your effectively the most valuable assets in a company, and you've got processes, and you've got tools as well. So our ability to kind of execute and be efficient, effectively influenced by these three components. So it's impossible to kind of have a fully efficient execution if you don't have these three kind of balance together. And this is a quick example, probably a bit interesting and a bit funny as well. So this is the plan, right? So you have a big plan, you got a strategy, and then there you go. Which is really awesome, right? So it works. You got a very professional driver that can do this. And I don't think don't want to even attend this. And in reality, right? So this is what happened, right? So things will break. Things will just, depending on obviously complexity in organization, the bigger the organization, the more likelihood that things will fail. And then you've got a partial solution. Let's come with a solution here, right? So you've got a robot holding a glass there, or a glass of a beer, and this is great, but it may not be what you need, right? So this is probably in the research world. They try and do things, and then you got the team, right? So which is great. So this is in a military sort of exercise there, which is amazing, right? So you've got people that are working really well together, and it's one characteristics of success. And you've got a full solution here, right? So this is what you want. So effectively, you've got a team, you've got people, you got the technology that can deliver that, right? So effectively, everything kind of in harmony, and therefore you'll be able to execute things as planned. And another twist that I wanted to sort of add is that all of this is great, but we have a new notion called what we call DevSecOps, right? So security, especially in today's world, becomes really, really important. And it's something that a lot of organizations are facing a lot of challenges, not only organizations, also individuals as well. Scammers everywhere. Recently, kind of trying to settle on a property myself, and it was really, really important to get everything correctly. And this one here is a quick illustration, right? So you can have the tools, but if you sort of cobble things up together, and you don't really feel that things will be secure, because things will be lost in translation, and you don't really know what what potential leakage of data and everything else. So what you want is well laid out system, well laid out processes, well laid out governance to ensure security is in place. Cool. So that is a little bit about DevOps. So I'll just take a quick pause there and see if there's any questions. Okay, no worries. And I'll be moving on to development workflow. So this is where we take a look at application, typical application sort of deployment. So you've got dev team, you've got operations team. They have, again, kind of usually a wall in between. So a lot of it become very fragmented. And as you can see here in the diagram, so you start with basically dev team asking, hey, give me some app resources or services in Azure, or in the on-prem world, potentially like a VM or something. And the resource then provisioned, and then development team actually script the deployment, and then operations team actually take a look at it, see if it meets their standards, and then tweak the deployment, going back again to the dev team, and then discover any kind of dependencies that don't maybe got removed because of security or some various concerns. And then it had to add that. And as you can see, this basically can happen many, many times. So it's basically a loop process that you have to go through, and basically the dev team as well as the ops team will need to be aware of various gotchas, and it's completely kind of a separation or a bit of a wall and in between dev and ops team. And finally, once you've got everything right, and that's that's probably you can put a number of X weeks or months, and that could be when basically application is deployed into your environment and production. So what if there's a kind of a better way to do this? So let me just see. So basically, in container world, with the container world, things will be different, right? So because we talked a little bit about how you build your application as a self-contained unit, you'll then effectively be able to merge some of those dev and operations activities. So as you can see here, it's a pretty interesting diagram. So you've got a sort of a non-container development flow, which we've just talked about. And basically there's some separation, there's some walls in between, and they don't typically communicate well with each other. And container development flow will change that. So effectively, what we have here is that a developer creates a new code, combine it with the external libraries here, and on their local machine. So they, again, that notion about what works on my machine should work on another machine with containers. It makes things a lot seamless compared to basically doing it in a traditional way. So once tested locally, then they commit the code to source control, and that code effectively, that Docker file as one of the main code that you have. And in production, when you deploy that in your environment, that code will effectively be used to run and build. So there's a level of consistency throughout, from dev tests to potentially staging or integration tests up to kind of production. So that way, visibility is key here, that people will actually see what's being deployed rather than in kind of a black box type scenario. And the good thing about this is that dev and ops can work together. They be able to learn, or I guess discover each other kind of dependencies in code, because it's all kind of defined as a declarative files effectively within the Docker file and other various source code as well, because it's effectively built on demand. Cool. The other thing that I wanted to sort of highlight here is that we've got a concept of continuous integration, where we've got a source code and we want to build, and then finally we want to test. And there's a bit of a difference between continuous integration and continuous deployment, in that the way it's being measured is different, right? So with continuous integration, the measurement is around frequent releases, and how many releases that you have, and mean time to release, mean time to deploy. This is typically common in a kind of a staging environment or integration environment, where you want to ensure that when you build new features, right, so you've got a different team that are working on certain things. With continuous integration, is that as soon as that particular team builds a feature, adding, for example, a button to retrieve report, for example, they can effectively deploy their code and then can be tested straight away into that integration and make sure that it doesn't break any of the parts of the application. So the other thing that also very common is continuous deployment. And this concept, or this notion, effectively kind of similar, but this brings kind of a different measurements, or different kind of way to measure the value of the actual deployment themselves. So you've actually got different components that are tested together in as part of that continuous integration. With this, you have a kind of a build or candidate release effectively for your app. And then you tested it on a QA or a very similar production environment, or close to production environment as you can. So you effectively measure it to what users are going to experience and going to replicate there. So that's so the measurement is deployment rate, mean time to release, and also availability of the application, which means that it works throughout the deployment. Cool. Another set of benefits with containers, again, is around ability for you to create and deploy apps fast. As a developer, you'll be able to define the exact packages that you need, because again, it's all within that Docker file, as we sort of saw before. And then IT operations can actually see them and can effectively respond and have a look at what are the dependencies, because it's all built in a self-contained way, and it doesn't impact. I guess it has that ability for you to actually see what dependencies are in place or are required for the application to run. So it's actually a happy medium for both sort of teams. The other thing is portability, right? So you've got ability for you to port the application, because container is a pretty small unit, and the management of the hosting environments, because you configure the application internally to container. It provides that flexibility for the operations team to manage the application's environment much closer. You can monitor the OS updates, you can apply security patches, and then on the OS, it's completely separated from the container side of things. And thing is cloud deployments, and it's something that we're going to be talking about quickly here. It's around how we can run this at scale. So we've invested quite a bit on a platform called Kubernetes. So we have Azure Kubernetes service, and this is basically a platform that allows us to run multi-containers, right? So say you've got different app, you typically because container is such a small unit, typically you need more than one container to run your application, whether that a 3-tier applications or two-tier application, whatever that is, and then you might need it for ability for you to ensure that the application is up all the time or within the SLA that you want. And basically, Kubernetes is very, very popular. 88% of enterprises using or adopting Kubernetes, and this is based on 2021 report. So I'm sure it's now it's becoming a bit more popular. Cool. Quiz time, quickly. Which of the following is not a benefit of using containers in CI/CD pipelines? Any guesses? So A, improve scalability and resource utilization. B, increase portability and consistency across different environments. And C, reduce security risks and vulnerabilities. Again, this is not a benefit. C. Excellent. Good guess. Thank you, Renee. Yeah, that's correct. So C is reduce security risks and vulnerabilities, and that's the reason is because while it does affect, it does actually have everything in a self-contained unit, you still need to ensure the dependencies are well taken care of, because a lot of the various dependencies that are typically used may get security patch and may actually get exposures to vulnerabilities. So it needs to still need to be maintained and fully monitored. Okay, thanks for that. So let's move on to a quick demo on using Kubernetes, right? So this is a very self-explanatory sort of video, but I'll try to explain it as we go. So we have a what we call a code space. I'm not sure if anyone used that. So it's code space. It's a feature in GitHub. It's a really fantastic sort of cloud-based development environment. So you don't have to have running a Visual Studio Code on your machine. So you can run it on the cloud. So what I have here, I run certain commands that allows me to build my application rather than kind of defining everything in, writing it from scratch. I can use this program called AKS Draft, which allows us to, build, even the Docker file. We want to build the various components that are relevant for our deployment. So I'll just continue that. So it will ask number of questions here, right? So enter the exporting the application, enter the name of the application. Then it creates a number of resources here, which we call Helm. So Helm is a packaging tool that at some point when you deploy applications in AKS or in Kubernetes, is very very popular. It's a package management for your containers, for your deployment within AKS, and allows you to I guess build all of the various components and package them up into what we call Helm charts. So we then use the container registry. So remember those container image that we build, we want them to be accessible from the cloud, right? So we want to push them to a central registry. If we build it on our local machine, it's only available on local machine, so we need to push them out to the cloud, and that's the container registry. And then you specify the container name. You specify the resource group within Azure, and then you specify the cluster name of your AKS. So once you've got the AKS cluster, then you just basically specify the cluster name where you want to deploy that. Again, it doesn't deploy it yet. To what it does is effectively creating all the deployment manifests within the files here, within the for the application. So here's a number of files that are created. So you can see, as you can see here, so there's a number of files here like Docker file. We've got Helm chart as well. We've got a number of Helm charts effectively need this kind of configuration or parameters that you actually feed in to that. And then you've got deployment manifest, which consists the set of containers as well. For example, you've got a front end, you've got a back end, you specify that in that deployment. And the service YAML is also important, which kind of defines the ports and how you want to expose that application. And namespace is basically ability for you to isolate different deployment within AKS cluster. Again, I've got some links that you can get on so that you can basically go through some of those basic concepts. All right, so moving on to this. So once I've deployed the application, I'll push them to my Git repo. And shortly after that, I'll be able to look at my Git repo. If I go to actions in here, it actually built set up a job that will deploy the Docker file, build the image, effectively push it to registry, as well as deploy it in your AKS cluster. So here's the soon will be. Oh, there you go. That's created there. So once you run that, there you go. So your application is deployed within your application service, within your AKS cluster, which is a pretty easy proposition if you use that. Again, there's probably something that we can something I'm going to provide you with some references so that you can try it out. All right. So quick things around kind of 5 things to consider before containerizing your app. Is your application's runtime already containerized? So this is, a lot of people, if they want to move to containers, these are some of the consideration, right? So, we need to ask our application. So it's very important to get a good understanding of the application. Some platforms like, .NET and Node.js, or they already have some Docker containers, so you can actually easily containerize them. And many vendors and open source or communities have done a lot of the work to containerize app runtime. So it's important to understand that first. Application is stateless or stateful. So stateless app is basically an application that doesn't save anything, right? So basically, there's a term in computer science like idempotent, which means that if you send something, then it will automatically give you kind of consistent result. Whether doesn't matter how many times you ask the result there, or ask for answers, or process that. And stateful apps, it effectively the opposite. It saves data. It needs some state to be maintained, but it can be containerized as well. The ability to do that has been improved throughout the years. Although we do recommend that if you can have stateless have a stateless app in your container, so that, because the idea there is that containers can be easily stood down, stood up, and making it more reliable for your application. Is the application already part of the CI/CD pipeline? So it's important to understand that. It might be easier if you already have CI/CD pipeline in your DevOps or CI/CD process. If you migrate them to containers, application design and environment config. An app that being containerized shouldn't contain any hard-coded config, right? So the idea there is that you want to externalize all of those various configuration, so that you can have a build artifact that you can put in your Docker file, and be able to expose those environments. And then finally, the refactoring side of things. So you may need to refactor your app in order for you to, depending on how old the app is, potentially if there's any various complexities that you have to sort of unpack, that would be kind of the last resort in order to get that app to be containerized. All right, so let me just quickly touch base on the microservices. So that we did talk a little bit about microservices here, right? So we've got a monolith, which is usually basically a big app, effectively, and the app maybe it's about accounting, right? So say an accounting software, and then it has a different parts in it. And what we do with microservices, we basically split up different services within that app to provide that specific business functionality. And then you can build a different set of containers for each of these effectively. So for invoice services, for public website, inventory services, and so on. So that makes things easier to test and deploy. So that's kind of the gist of that. Cool. We're very, very close on time. I would just want to close this with impact of generative AI to developers, and I think with some confidence that everyone knows about ChatGPT in there, and that we know that we have world of copilots. So the main message I want to highlight is that it will be a game changer for a lot of people, and especially developers, because with Copilot, you can easily go, with GitHub Copilot, I can just type in, I'll write a function to validate a password is strong here, right? And what it does effectively creates the function for me. So it improves the flow, so that you don't have to go out, to the internet to be able to, search for the code that you want, because it stays within the same context, and that's really, really good. And the main thing here is that it's going to be a positive upshot and upside for developers, because it will unleash our creativity. It will make coding much more accessible. It will become our co-pilot in other ways as well. Not only the coding part of it as well, but also, M365 and various products that we have with Microsoft. It will unlock faster iteration. It will make, importantly, work much more enjoyable. Cool. So that's it from my side. I think, Renee, are we sort of on time? Do we have questions?
Sorry, I was muting. Yeah, we're just slightly over time, but people are still here. So if anyone has questions, feel free to ask them now. But yeah, big thank you, Vic, for coming along, getting this prepared on maybe 2 days' notice. It's been fantastic. I've really enjoyed all of the stuff and getting knowing a bit more about your ideology about containerizations, because I think like you can learn the tech, but I think knowing like why we put things together is really important. So that's been really great. And obviously the cool stuff on AI at the end, which is like, there's a lot of cool stuff out there. I've been playing around with it. It's very cool. So very exciting. Just give everyone a second to ask any more questions. Otherwise I'll just present what we're going to be doing in the next session. Cool. Okay. Next up, coming on the 23rd of June, there's a smaller gap between these sessions. We've got Azure Fundamentals Preparation. So if you're keen to learn about the diverse range of different Azure technologies and stuff, this is, your go-to one. We'll be covering all the basics of Azure and what to use when, where, basically, and how it all fits into the world of cloud. And this is kind of the content you need if you want to go and do your Azure AZ900 as a fundamental certificate. So yeah, this will be a really great course with a really great presenter, Sonia Cuff. So she'll be coming along next time. But yeah, that'll be a really terrific one. Don't miss it. It'll be super cool. Yeah, but unless we have any questions, I'll say thank you one more time to Vic. Thank you for coming along. Thank you everyone who joined the session today, and I hope anyone who's watching the video later, you've had a great time as well, and we hope to see you all at the next session. And I'm just going to stop the recording now.
Thank you, everyone.
Thank you.